Alright, so in this video we're going to be taking a look at systems of equations. So first let's find out what we're even solving for when we're solving a system of equations. All that's going on is we have two equations that if they were to be placed on a graph, and we're going to graph these real quick, the solution is where these two lines intersect. So let's graph the first one here, and I have another video on graphing functions, so if you need to take a look at that, take a look at that. But basically, we have our intercept here, so that's a point here. Our slope is negative 5 over 3, so we're going down 5, 1, 2, 3, 4, 5, 1, 2, 3. And then our other line, so let's draw this line through all the way. Right, so then our other line has an intercept at negative 3 and a slope of 1/3, so 1, 2, 3. So these points intersect here, and that is the point 3, negative 2. So the solution to this system of equations is 3, negative 2, or x equals 3, y equals negative 2. But you don't always have a graph, and sometimes the numbers are huge that you can't really even graph them. So what do you do in those situations? Well, there's two methods. There's substitution and there's elimination. So substitution is basically the idea that y here is the same as y here. And that goes for x's as well. It doesn't really matter what variable. In this case, we're just going to be substituting y. But we know that y is also equal to 5. But that means since this y is the same as this y, that 5 is the same as this y here. So we can just plug that 5 in here. We'll get that 5 is equal to 2x plus 5. Then we solve it just like any other equation. Minus 5, minus 5. We get that 2x is equal to 0. That means that x is equal to 0. And we don't even have to solve for y here because they told us that y is 5. So it means our solution is 0, 5. All right, that's a really easy one. Sometimes it'll be something like this, where you have y and y, but they're both equal to equations. So again, same idea. Y here is equal to y here. So it means 6x plus 1 is equal to this y as well. So we can just go ahead and plug that in. So we'll get that 6x plus 1 is equal to 2x plus 5. And now we can solve for x. So I'm going to go and subtract 2x from both sides. Get 4x plus 1 equals 5. Minus 1, minus 1. 4x is equal to 4. X is equal to 1. But we're not done yet, because we don't know what y is. In order to find y, what we have to do is we take this x that we found, and we plug it into whichever equation we want. I'm going to go with the bottom one because the numbers are a little easier. So we get that y is equal to 2, and now instead of x we have 1, plus 5. That gives us y is equal to 2 plus 5, which is 7. So then the solution of this equation here is 1 and 7. So again, nothing too bad. Now where stuff starts getting a little trickier is around here, where we don't have a y equals for both of the equations. So the same idea applies though, is we have a y here. That means we can plug it in for y here. But that takes a few extra steps now. But y here is 6x minus 11. That means it's the same as the y here, and we can just substitute that in. So now our new equation is negative 2x minus 3, but now instead of y, what we have is this 6x minus 11 is equal to negative 7. So then we go on, we use distributive property here to simplify, and we just solve the equation. So we have negative 2x minus 18x plus 33 equals negative 7. We get negative 20x plus 33 is equal to negative 7. Subtract 33 from both sides. we'll get that negative 20x is equal to negative 40. So it means that x is going to be positive 2. And now, same thing we did in the last question, we're going to plug that in up into the first equation so we can get y. Let's get that y is equal to 6, and now instead of x, we're using the 2. I'm sorry for changing the place that I'm writing this in, it's just kind of running out of room a little bit here. But that just gives us that y is 12 minus 11, which is the same thing as 1. So our answer is going to be 2, 1. Now when the stuff gets really tricky is when we don't have a single equation where it's just one variable, like y equals or x equals, where we have to manipulate the equation to get y or x on their own. So this is about as hard as substitution gets. So for this one, I'm going to use the bottom equation, and I'm going to try and get y on its own. So first step is going to be manipulating the equation to get one variable on its own. So what we can do here is we can add 5x to both sides, and that'll get negative y on its own. So now all we need to do to get just y is divide by negative 1 on both sides. And we'll get that y is equal to negative 5x minus 21. So now when we substitute this y back into the equations, we have to use a different equation than the one that we manipulated. So we manipulated the bottom equation, so that means now that we have y, what it's equal to, we have to plug that into the top equation. And now if we go on to do that, I'm going to erase some stuff here. We get that negative 4x plus, and now instead of y, we have negative 5x minus 21 is equal to 6. So clearing up some more room here. So now we have negative 4x minus 5x minus 21 equals 6. Negative 9x minus 21 equals 6. Negative 9x, and if we add 21 to both sides, we'll get that negative 9x is equal to positive 27. So now if we divide both sides by negative 9, we'll get that x is equal to negative 3. And now we can plug this one into any equation to find y. So I'm going to use the top equation. So now we have negative 4 times negative 3 plus y equals 6. So that gives us a positive 12 plus y equals 6. And in order to get y, we just subtract 12 from both sides. And we're left with y is equal to negative 6. So then our final answer is negative 3, negative 6. So now moving on to elimination. Elimination is basically like adding or subtracting something, except now we have variables. But the main idea here is to get rid of one of the variables so we only have one left. So in this example here, we're going to try and get rid of this x. And we can do that just by adding these two equations together. Negative 4x plus positive 4x is going to be 0. 2y plus 8y is going to be 10y. And negative 12 plus negative 24 gives us a negative 36. So if 10y is equal to negative 36, that means that y is equal to negative 3.6. We want to solve for x. We just have to plug that in to either one of these, and we can find x as well. So negative 4x plus 2 times negative 3.6 is equal to negative 12. So we get that negative 4x minus 7.2 is equal to negative 12. So then add 7.2 to both sides. We get that negative 4x is equal to 4.8, negative 4.8. And that means that if we divide both sides by negative 4, we'll get that x is equal to positive 1.2. So our final solution is 1.2, comma, negative 3.6. That's our answer. So now in this case, it's a little bit trickier because we have 6y in both of these, but we can't just add them because none of them are negative. So what we have to do is we have to subtract. But when we subtract, that's the same thing as putting parentheses around the whole thing that we're subtracting out. So 6y minus 6y gives us 0. Now we have negative 6x minus 3x. So that's going to give us negative 9x. And now we have 6, but here's a negative 12, but we're subtracting. So a negative times a negative gives us a positive. So that means 6 plus 12, and that's going to be 18. So now we have negative 9x is equal to 18. Divide both sides by negative 9. We'll get that x is negative 2. And we can plug that in and find y. So I'm going to use the bottom equation for this. Get that 6y plus 3 times negative 2 is equal to negative 12. 6y is equal to 6y minus 6 is equal to negative 12. Add 6 to both sides. We get that 6y is equal to negative 6. Divide both sides by 6. We get that y is negative 1. So our final answer is negative 2, negative 1. So now when we don't have a nice one like we did before, where we have 2 6s or 2 5s or whatever, none of these are exactly the same, but we can manipulate it to make them exactly the same. So what we can do to the top equation here is we can multiply it by 3. And that way we'll have a 9x and then we can subtract it out. So 3x times 3 is going to give us 9x minus 7 times 3 gives us 21y. And 16 times 3 gives us 48. And now the bottom equation stays the same. And kind of like in the last example, we're subtracting again. So that gets us 9x minus 9x gives us 0. Negative 21y plus 5y would give us negative 16y. And then 48 plus 16 would give us 64. We're going to divide both sides by negative 16. That's going to give us that y is equal to negative 4. And now plug it into the top or the bottom. Actually, I'm going to use the bottom for this one. And we can find x. So now we have 9x minus 5 times negative 4 equals negative 16. So now if we simplify, that's 9x plus 20 equals negative 16. So that means 9x is equal to negative 36 if we subtract 20 from both sides here. Divide both sides by 9. We get that x is equal to negative 4. So it's negative 4, negative 4. And that's our solution. Now this is the hardest version of elimination that there is, because there's nothing that we can take a single equation and multiply to be equal to the other equation. So what we have to do here is we have to multiply both of the equations in order to then find the greatest common or the least common multiple in this case, so that we can subtract one of them out. So what we can do with the top one here is we can multiply it by 4. We can take the bottom one and we can multiply it by 7. So the top one multiplied by 4 is going to give us negative 28x, negative 32y, and that's all equal to 36. And the bottom equation multiplied by 7 will give us negative 28x plus 63y is equal to 154, or negative 154, because it's a negative 22. So now, again, we're going to have to subtract out because they are the same sign, so we have to subtract them out. So negative 28x plus 28x, that's 0. Negative 32y minus 63y is going to give us 95y. y. But it's not going to be positive, my mistake. It's going to be negative. And then we have 36 plus 154, which is 190. So we can divide both sides by negative 95. And we'll get that y is equal to negative 2. And now we can just plug that into one of these equations here, and we can find what x is. So negative 7x minus 8 times negative 2 is equal to 9. Negative 7x plus 16 is equal to 9. Subtract 16 from both sides, we'll get that negative 7x is equal to negative 7. And we divide both sides by negative 7, we'll get that x is equal to positive 1. So in our final solution is 1, 2, negative 2. So that's it for elimination. So now moving on to infinite no solution plus perpendicular lines. So this example here, if you notice, both of them have the same slope. If we were to solve this using substitution, what we would get would be 2x plus 3 equals 2x minus 3. And if we were to subtract 2x from both sides, we would end up with 3 is equal to negative 3, which is never possible. So this is a no solution. And these lines are parallel because of the same slope. So if we were to put it on the graph, one of these intercepts is here, going up to one to the right. So it looks something like this for the top line. And the bottom line goes through negative 3, and it has the same slope. So the reason this is a no solution is because these lines will never touch and they'll never intersect. So when you're solving it with substitution or elimination, if you get a number is equal to a number that's different than itself, so like 3 is equal to negative 3, which isn't true, it's always going to be no solution. Or if you're graphing, or if you just notice that the slopes are the same, that's always a no solution, parallel lines. Moving on. So this one, if you didn't notice, this equation is just 2 times the top equation. So if we were to solve this using substitution, plugging this in here, we'd get 2 times 2x plus 4 is equal to 4x plus 8, which would be 4x plus 8 is equal to 4x plus 8. If we were to simplify this further, we get that 8 is equal to 8. So something that we get is like a number is equal to itself, which is always true. That's infinite solutions. And that happens because they are the same line and they just lay on top of each other. So if we were to graph it, it would just be the same line, and it's always going to be intersecting. It's the same. So now moving on to perpendicular lines. So a perpendicular line, the way you find it is you take the slope of whatever equation you have, and you find the reciprocal of it, and you change the sign. So in this case, our slope is positive 1/5. So the slope of the reciprocal, or the slope of the perpendicular line, is the reciprocal. So we're going to flip these two and change the sign. So the reciprocal slope would be negative 5/1, or just negative 5. So in this case, we're going through the origin. The perpendicular line is going to be y equals negative 5x. And because it goes through the origin, that means it doesn't have a y-intercept. So that's just the answer. So now for this question, the same equation as before, but now we want a perpendicular line that goes through the point 1, 3. So the way we're going to do that is, again, we found the slope already, but we haven't found the y-intercept necessary to make it go through this point. So all we're going to do is we're just going to plug in 1 for x and 3 for y to find the intercept. So that'll give us 3 is equal to negative 5 times 1 plus b, or 3 is equal to negative 5 plus b. Add 5 to both sides, and we'll get that b is equal to 8. So then the equation of the perpendicular line of this equation here, going through this point, would be at y equals negative 5x plus 8. That would be the answer. And if you want to graph these, I'm just going to graph the top one here, just so you can see how the perpendicular lines look. So this equation, the graph of it would look like 3, and then 5 to the right, 1 up, about here, about here. And then the perpendicular line has a slope of negative 5, and it's going through the origin. Would look something like this. They intersect here, and they form a perfect 90-degree angle. And that's it. That's perpendicular lines, no solution, infinite solutions, and just systems of equations. Thank you guys for watching. If you're looking for practice problems, there should be some linked in the description below. If you like the video, please leave a like. It's much appreciated. Really helps get the content out there for other people to see. And yeah, have a great day.